everyone, thank you so much for joining this video. Today we're going to be looking at the characteristic reactions of halide ions. So we're going to look at the precipitation reactions including ionic equations of aqueous anions, chloride, bromide and iodide with aqueous silver ions, followed by aqueous ammonia and their use as a test for different halide ions. Now we're going to look at the reactions of the halide ions. And so halide ions are always 1- ions, and that's because the halogens are in group 7. So they want to gain an electron. And so they form 1- ions, and so this means they can act as reducing agents because they can give away this electron to reform halogens. And so it reduces the thing that's trying to be reduced. And the thing to know is that reducing ability increases down the group. And this is because of the electron shells again, because the electron shells increases going down the group. And so this means that outer electron gets easier and easier to donate because the force it feels from the positive nucleus is smaller when you go down the group. Now we're going to have a look at reactions of sodium halides with concentrated sulphuric acid. So the first one we have is sodium chloride. Now, sodium chloride reacts with sulphuric acid to form sodium hydrogen sulfate and HCl gas. And the HCl gas is actually comes out as steamy fumes. So that's when you know that this reaction has happened. And all the oxidation numbers haven't changed. So it's not a redox reaction. And this is just an acid-base reaction. So the acid is sulphuric acid, and sodium chloride is acting as the base. Sodium fluoride does the same thing, but it produces hydrogen fluoride, which is a really dangerous gas. Now we're going to look at sodium bromide, and this is two different reactions which are happening. So the first reaction that happens is the same acid-base reaction as for sodium chloride. And so we have sodium bromide reacts with sulphuric acid to form sodium hydrogen sulfate and the hydrogen bromide. And again, the hydrogen bromide comes out as steamy fumes. And this is the acid-base reaction. And then the second reaction that occurs is because the bromide is better at reducing compared to the chloride. And so oxidation of this bromide occurs and reduction of the sulphuric acid. And so this is a redox reaction. So we have two bromide ions reacting with two H+ ions and sulphuric acid. And this forms sulfur dioxide, water and bromine. And the really important thing to remember about these reactions is what is formed and how they have distinctive features. So we get steamy fumes, and sulfur dioxide is a colourless gas, and bromine is a brown-orange gas, because you'll be asked questions as to what's produced and also what would you expect to see. So how they've actually got this bottom equation is that firstly they have bromide ions which have been oxidized, so they form bromine molecules and 2 electrons, and also the sulphuric acid, they've reduced that to form sulfur dioxide. And if you can't remember how to form these redox equations, then quickly go back to the redox chapter to have a look and remind yourself. So they've got these two equations where they've converted this sulphuric acid to sulfur dioxide by reducing it, and the bromide ion they've oxidized, and they've basically just combined these two equations together to form this equation. So now we're going to look at sodium iodide, and this is also two reactions, but we've got some extra steps in the middle. So first of all, again, what happens is an acid-base reaction. So important thing to remember is that with all of these, the first thing that happens is an acid-base reaction, and so steamy fumes is always produced. So we have the sodium iodide reacting with sulphuric acid to form sodium hydrogen sulfate and the hydrogen iodide, which are the steamy fumes. And then because the iodide ion is so good at reducing, it reduces the sulphuric acid further. And so first what happens is that, so we're looking at the steps in between. So we have two iodide ions reducing sulphuric acid. And first of all, we obtain some iodine, sulfur dioxide, and water. So again, we get sulfur dioxide, which is a colourless gas. And this is the same as what we got for the sodium bromide. And then what happens is that, again, it's so good at reducing the iodide. The iodide is so good at reducing that it reduces the sulfuric acid some more. And so what's formed after is some more iodine gas, and then sulfur, the solid, and this is a yellow solid, and also some water. And then the last thing that occurs, so overall what occurs is that it reduces the sulfuric acid to hydrogen sulfide, and this gives off a very distinct rotten egg smell, water and iodine. So the iodine provides some purple fumes. So from this reaction, what we get is we get some hydrogen iodide, so that's steamy fumes, and we get some sulfur dioxide, which is colourless gas, sulfur solid, which is yellow, some hydrogen sulfide, which gives off a rotten egg smell, and also iodine gas, which will be purple fumes. And so it's really important to remember all of these equations and all the distinctive things that they produce, because you'll definitely be asked about it. The reason we can tell why all of these extra things are produced is because of the reducing power of the iodide, is because if we look at the oxidation numbers of sulfuric acid, hydrogen sulfide, sulfur dioxide, and sulfur, then we'll be able to see the oxidation number decreases. And so first, what we have is that we have sulfuric acid, which is H2SO4, and so the sulfur has an oxidizing number of +6. And then if we have a look at what is produced, we have this sulfur dioxide here. So sulfur dioxide, the oxidation number of sulfur would be +4. So it's been decreased because the sulfuric acid has been reduced. And then what's formed next is the sulfur. And so this is now going to have an oxidation number of 0 because it's an element. And so again, the oxidation number has decreased, which means it's been reduced further. And then the last thing which is formed is this hydrogen sulfide. And so the oxidation number of the sulfur would be -2. So this is how we can tell that it is because of the reducing power of the iodide that we can form all of these different things. So now we're going to look at some questions. So for the first question, when concentrated sulfuric acid is added to potassium iodide, solid sulfur and a black solid are formed. And A tells us to identify the black solid. So we know that when we add potassium iodide to concentrated sulfuric acid, we have quite a lot of things forming. We have a rotten egg smell and some yellow sulfur and misty fumes, and there's quite a lot of other ones as well. And the black solid which is formed that we need to remember is solid iodine. So the solid iodine is the black solid. So it's easier just to remember everything that is formed and all the different aspects of them. So like what they look like and what kind of distinctive features they have. And so it'll really help you with these kinds of questions. And then for B, deduce the half equation for the formation of sulfur from concentrated sulfuric acid. So this is just a question of writing half equations. So if we start off with sulfuric acid, and then we end up with sulfur, first we need to balance everything that isn't oxygen and hydrogen. So that's already done because we've balanced the sulfurs. And then we add in waters to balance the oxygen. So we need 4 waters. And then we add in H plus ions to balance the waters, or the hydrogens, sorry. So we have 8 on this side, and we already have 2 here, so it must be 6 H pluses. And then now we add in electrons to balance the charges. So we've got plus 6 on the left, so we need 6 electrons on the left to balance it all. And then for C, when iodide ions react with concentrated sulphuric acid in a different redox reaction, the oxidation state of sulfur changes from plus 6 to minus 2. The reduction product of this reaction is a poisonous gas that has an unpleasant smell. Identify this gas. So the gas they're talking about is that rotten egg smell. And so we just need to remember what that is. So the answer is hydrogen sulfide. Or you can just remember the chemical formula of it, which is H2S. So before I move on to question 2, feel free to click off the video and try it for yourself first. So it says a yellow precipitate is formed when silver nitrate solution acidified with dilute nitric acid is added to an aqueous solution containing iodide ions. Write the simplest ionic equation for the formation of the yellow precipitate. So what we're doing is we're forming silver iodide. And so we have silver ions in solution, and we also have iodide ions in solution. And so what this forms is silver iodide, which is a precipitate, so it's a solid. And then for B, state what is observed when concentrated ammonia solution is added to this precipitate. So now we need to remember our tests for these precipitates. So extra tests that we do is that we add in dilute ammonia and then concentrated ammonia. And we do this if the colours are quite similar, because silver chloride produces white precipitate, silver bromide is a cream precipitate, and silver iodide is a yellow precipitate. So sometimes these 3 colours might be actually very, very similar. And so this is why we add in the ammonia to further distinguish them. So the sodium chloride dissolves in dilute ammonia, and then silver bromide dissolves in concentrated ammonia. And the thing to remember about silver iodide is that it does not dissolve in dilute or concentrated ammonia solution. And so the answer is that nothing will change. So there is no visible change.